Okay, 3.3 display data. So we're going to go over different types of data. Categorical data. This can be broken down into categories. Okay, this is qualitative data. Data consisting of categorical variables where the data is organized into groups based on labels, such as blood types. Okay, blood type is not a number. Citizenship, that's not a number. It's a quality, right? Favorite foods, favorite color, sex, age, education level. Okay, now numerical data. This is quantitative data, right? So when you think qualitative, you think quality. Okay, this is a description of something using words, right? Using words. And when you think quantitative data, you think quantity. And you think a description using numbers. Okay, this is when data where its values can be presented, obviously, in number form, such as height, weight, age, number of movies watched, IQ. Okay. Then we have something called continuous data. This is data that takes on any and every number within a range of numbers. And when we draw this, such as this example, we draw it without using our pencil, or sorry, taking our pencil off of the paper. So we have like two endpoints, but we hit every single number between those two endpoints. Okay, such as measurements, volume, area, length. Okay, you don't go to sleep and you're 5'6" and then you wake up and you're 5'7". This is a gradual thing. You don't jump up by inches. You hit every single height between 5'6" and 5'7". Okay, it's like you grow to that height. And now discrete data. Data that takes on only certain values within a range. And so it takes on specific values only. So when drawing a graph, it's drawn by taking your pencil and like lifting it off of the paper. And it's usually drawn as independent points. Okay? An example of this is number of goals that you score in a soccer game. Okay, 0, 1, 2, 3. Okay, you cannot score 0.2, 0.5. It doesn't make sense. Okay, also money. Even though money is 2 decimals in Canada, say you can have $2.75, right? Even though there are decimal numbers there, it's finite. It finishes at 2 decimals, so that's actually discrete. So data may be displayed in different ways. Okay, we could make a frequency table, and what this is it's a table that shows the number of times a variable occurs in a set of data. Okay, this is an example right here. So we could have maybe like the day of the week, then we can have the number of customers. So this would show the tally, the frequency of the number of customers per day. So in the middle here, these this is called a tally of the number of customers. And then what we would do is we would count these up. I'll do lighter. We would count these and we would tally them up, count them, and record 18 as the frequency. So what this does is this is used to help show which options are more or less common. So example, how many customers come into a store and make a purchase on each day of the week? Okay, another way that we can display data is a circle or a pie graph. And what this is it's like a visualization of the percentage or the proportion of the people out of the entire population. So what ends up happening is the number of successes is divided by the total number of people to get like the percentage or proportion. And then that proportion of the whole is multiplied by 360 degrees to give us an angle. Okay, this gives us an angle. So this is used with categorical data to show a visual representation of the percentage or allotment of the whole. Okay, so for example, on this one, grade 8 students were asked what their favorite activity is out of bowling, baseball, basketball, football, and tennis. And these are the responses. If you can see, this angle here for tennis is the biggest angle, so that's going to be the biggest proportion. We visually see this blue as the biggest. And then when we're looking at here skimming, I mean, basketball and bowling are very similar, but ultimately basketball here, this piece of the pie, this basketball was like the least popular. So this is really easy to see the most popular and the least popular. Okay, and now bar graph. This is a graph that shows complete data with rectangular bars, which is over here. They can be vertical or it could be a horizontal bar graph. For the scope of this course, we're going to be doing vertical bar graphs. And the heights of the bar graph are proportional to the values that they represent. So for example, this one, favorite color for green, this represents 20 students. Blue, this represents maybe 14 students. And red, this represents, it could be 15, this could be 10. It's just approximate here on this. Let me see. Yeah, I would say this would be 20, this would be 15, this would be 10. And this is a good visual representation to compare quantities in different categories when the data do not need to be in any specific order. Okay, categories, colors. This is a category. Okay, example, a class was surveyed and asked what their favorite color was out of blue, green, and red. And here were the results. A pictograph, charts that represent data using icons, right, like a picture, and images relevant to the data, stated using a legend or a key. So either the full picture is used or a fraction of the picture is used. This is super approximate. Okay. So when is this used? It's used to provide visual representation to compare and when approximate values are appropriate. So approximate. Okay, Sal collected data on the number of apples sold in the cafeteria and displayed it in this pictograph. So we can see that one full image of an apple represents 10 apples, and then this represents 5 apples. I actually like this. This right here, the second part of the legend, the picture is half of the apple, so it's half of the 10, which is 5. I like that because a lot of times pictographs don't actually include this. So instead, like you're kind of guessing, is it like a third of the apple? Is it 3 apples? Or is it 2 apples? Or is it 4 apples? Right? You're sitting there guessing. But I like this. It was either 10 or 15, or sorry, 10 or 5. So in January, 10. In February, 10, 20, 30, 40. In March, 10, 20, 5. And then in April, 10, 20. Just as an example, how to read that. Those are the number of apples sold. Okay, now finally, histogram. Histogram is a bar graph in which the areas of the bars are proportional to the frequencies of the values of the variable. And the bars touch. That's important. These are used for continuous variables whose values can be arranged in numerical order, such as weight, temperature, or travel time. Okay, it's appropriate to use intervals when there's like a larger range. You don't want to sit here and graph every single number between 0 and 30. So instead, we're going to group them into intervals of 5. So 0 to 5, 5 to 10, 10 to 15, okay, and so on. So example, Steve surveyed students in a grade 11 class and recorded the time it takes them to get to school. So this is maybe 2. So 2 students took between 0 and 5 minutes. And then 5 students took between 5 minutes and 10 minutes, okay, and so on. 10 students took between 10 minutes and 15 minutes to get to school. Example 1, bar graphs and circle graphs. Okay, Dexter has a part-time job at a music store. The table below shows his expenses last month. Complete the table by calculating the percent and angle. So percent is here, and the angle of measure in the circle of his expenses, and then display the data on a circle and bar graph. Okay, we're going to do that below. Then answer the questions below. So, talk about this. We can see the expenses here. So there's entertainment, clothing, cell phone, lunch, transportation, and rent. And then the amount, $100, $225, $50, $75, $80, $150. So the total amount that this individual is spending is $680, right? Amount is in dollars. So what we want to do is we want to figure out what percent of the whole is entertainment. So 100 over 680. And this is, so these are going to be ugly numbers, 0.147. So I'm going to say 15%. Okay, clothing is going to be 225 over 680. So I get 33%. Cell phone is 50 over 680. I get 7%. Lunch is 75 over 680. So I get 11%. Transportation is 80 over 680. I get 12%. And rent is going to be 150 over 680, which is 22%. Okay, so if we take a look at this percent column and we add up all of these percentages, this actually totals to 100%, which is exactly what we want because we have the proportion of every single expense for Dexter out of the 100% of his money or his budget. Okay, so 15%, which is 0.15, we multiply that by 360 degrees. This is going to be too big, but that's okay. And we get 54 degrees. Okay, clothing, 0.33 times 360 degrees, right? So we're thinking what's 33% of our entire pie? So our entire whole. Let's go 119 degrees. Okay, what's 7% of our entire pie or our total whole? 25 degrees. Okay, we want to do this for all of these. 11%, 12%, and then 22%. So we get 40 degrees. We get 43 degrees. And we get 22 degrees. Oh, sorry, 79 degrees for 22%. Now, if we go down this third column and we add up all of these degrees, so 54, 119, 25, 40, 43, 79, all of these degrees, these all add up to 360, which makes sense because in a circle, there's 360 degrees. Okay, so now in a circle, we have to think, so just throwing this out there, in a circle, this is 180 degrees, right? So half of it. So a quarter would be 90 degrees, and that's what I go based on, okay? So I'm going to start with rent, 79. That's going to be a little bit less than 90 degrees, okay? Because it's almost 80 degrees. So instead of 90 degrees, which would be here, I'm going to draw it here. And it can be approximate. I mean, if you were in elementary school, you brought out your protractor, you could actually draw this very accurately. So this is going to be rent. Let's see this darker. Okay, which is 22%. Okay, now transportation, 43 degrees. So 43 degrees is it's about half of 90, right? So another one, so this would be 90. Half of that is going to be 45 degrees. Okay, so if you rotate your paper and you're looking at this, so say this would be 180. This would be 90-ish. Let me see. That would be 90. So let's put it here. Almost half of 90, the transportation. Okay, and transportation is 12 degrees. Or sorry, 12%. Okay, lunch, 40%. So 40% is lower than 45%, but let's kind of do the same idea. So transportation, and then this would be about 90 degrees from there. So let's go 45 degrees would be here. Let's go a little bit less than 45 degrees. So let's go, this would be 11%, this would be lunch. Okay, cell phone is 7%, which is 25 degrees. So if I were to draw this is the 90 degrees. So this here would be 45 degrees. So it's almost like it's just over half of what the 45 would be. So let's go here. So cell phone. And this is 7%. Okay, 119 degrees for clothing. So this is 33%. So this is the third. Okay, so a third would be, if you think of like a peace sign, a third would be like this. I'm going to draw over this in darker green. That's fine. Okay, so this would be a quarter, right? 90 degrees, but we're looking for 119. So it would be 20 degrees more. So I'm going to say it would be, so instead of being here, let's draw it about right here. So this would be clothing. And this would be a third, so 33%. And then that gives us entertainment at 15%. Which is 54 degrees. So that quarter and a little bit more, which makes sense because these two approximately would be a quarter. Now let's go ahead and display um, these expenses in a bar graph. So we have, okay, 1, 2, 3, 4, 5, 6. We have 6 items, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 positions that we could put for bars. And for bar graphs, they don't touch. So let's just put these in order. Entertainment, clothing, cell phone. Okay. So I'm actually going to go up the side. Oh, this is going to be worse. Okay, I can't go sideways because of my stylus. Entertainment is going to go here. Clothing, cell phone. Okay. Clothing's going to go here. Cell phone. Lunch, transportation, rent. Okay. All right. And if we take a look at the amount of money spent, so this is going to be expenses versus amount. Okay, so let's label this axis expenses and this axis amount. And that's going to be in dollars. Okay, and we're going to go up the amount column. And the biggest number that we have to budget for is $225 for clothing. So we will start at 0, 1, 2, 3, 4. You know, we could probably do by $25 increments. Okay, so 125, 150, 175, 200, 225. Okay, and now let's graph. So we have $100, $225, and $50. So entertainment is $100. And we're of course doing this with a ruler. Clothing is $225. Okay, 50, 75. Okay, cell phone is 50. Lunch is $75. In the expenses, and we have 80 and 150. So 80 is kind of a little wonky of a number. It's not exactly, but that's okay. We go up to 75, and it's somewhere between 75 and 80, or sorry, 75 and 100. It's just over $75. Okay, and rent's 150. All right, there we go. Here's our bar graph. Okay, bars don't touch. Now let's take a look at this. These two questions. Which, oh, and you know what? We could title this. We could call this Dexter's expenses. So, which graph best displays Dexter's expenses? Justify your answer. Okay, so this is kind of like a twofold. So the thing is, with a pie graph, pie graphs are better at showing proportion. So if you want to say, or circle graphs. So pie graph, when we want to know the proportion of his money and where it's allotted. Okay, but if we want to compare how much more money he spends in one area than another, then it's bar graph. So bar graph, I'll do this in another color so it really pops. Okay, bar graph. And this is kind of going into this answer here anyways. When we want to compare like maybe how much more or less Dexter spends on one expense than another. Okay, super long sentences. This question, I just want to touch on this. When is the bar graph the best choice to display the data, and when is the circle graph? We kind of explained it with the question in part A. So that one's done. We'll blend those answers. Example 2, histograms. Data was collected on a class of 20 students regarding the average number of hours spent weekly watching a screen. So a screen could be TV, computer, cell phone, iPad. Okay, so let's do A first. Complete the tally below for the number of students in each interval and then determine each frequency. So we have a list of numbers here representing the number of hours on the devices. And then we have a chart. So on the chart, we have interval, tally, and frequency. So the interval 0 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and then over 26 plus is like anything over 26 hours, which is disgusting. Okay, so let's go ahead and tally these. I usually do like 3 at a time. So 5, 20, and 27. So 5 would go from 0 to 5. 20 would go 16 to 20. And 27 would be up here, 26 plus. Okay, 20, 18, 19. Those actually all go on the same interval. 20, 18, and 19. 26, 17, and 14. So 17 is here, 14 is here. 2 and 3 go together down here. 9, 7, 10. 9, 7, 10 all go here. 13 and 13 are going to go in the same, so those are going to go here, 13 and 13. 22, 29, 22, 29, 33 and 25. 33 and 25. So we don't have to total a tally because we're not going to like take all these dashes and total them again, but let's go ahead and write the frequency and then we'll total the frequency. So this tally from 0 to 5, we get 3. From 6 to 10, we get 3. From 11 to 15, we get 3. 16 to 20, we get 5. 21 to 25, we get 2. And 26 plus, we get 4. And if we add these all together, we get a total of 20, which makes sense because in the original question, it says that they interviewed 20 students. So let's now create a histogram. So what we want to do is we want to put the intervals at the bottom. So remember, this is number of hours versus frequency. So number of hours, like on a device, versus, and then this one's going to be frequency. Okay, so we have 1, 2, 3, 4, 5, 6, 7 boxes. We have 1, 2, 3, 4, 5, 6 intervals. I usually leave the first one. So this is going to be 0 to 5. We can make the interval like that if we want, or we can put 0 to 5. Okay, and do 6 to 10, 11 to 15, 16 to 20, 21 to 25, and then 26 plus. Okay, and then for the frequency, the highest frequency here is 5, so we can just go up by ones. 1, 2, 3, 4, 5. We could have went 2 boxes as 1, but that's fine. So 0 to 5, we're going to get 3. We're going to go 3 up, obviously using ruler. 6 to 10 is also 3. 11 to 15 is also 3. And then we go up to 5. And then we're down to 2. And then we're up to 4. Okay, so here is the histogram to show the number of hours that these 20 students were on their devices. Okay, we can call this number of hours on devices. Okay, I did this, but let me read B. Complete the frequency histogram, which we did. Fill in the appropriate axis labels and titles. Note, histograms record continuous data, and there are no spaces between the bars on the graph. Okay, it's continuous data because it's the number of hours, right? So it's time. Even though we did kind of use discrete data, these are rounded, but that's okay. It does still show continuous data. So now, when comparing histograms to bar graphs, what is the same and what is different? Okay, so both have bars. Okay, but we can say histograms, bars touch, and we say bar graphs, bars don't touch. Okay, and then also we can say histograms show continuous data, and use intervals, whereas bar graphs show just, let's go categorical, and discrete data, and use either just like one number at the bottom or a category. Along the x-axis. Example 3, interpreting data. The data below was collected from the staff at a local cinema. Okay, so these are people who work at the movie theater. Okay, favorite type of movie. So they interviewed people and asked if their favorite type of movie was comedy, action, romance, drama, or science fiction. So sci-fi. Okay, so these numbers were taken and put into this bar chart. The bar graph. Comedy, action, romance, drama, science fiction. Okay, so A asks, which type of movie is the most popular? Well, we can take a look at this bar graph and we can quickly, like our eyes are going to be drawn to romance here because it is the highest bar. Okay, so romance. And I'm going to put in brackets 6 just to say like how many people, how many staff voted for romance. And then the least popular, I'm looking at this bar here, drama. And only one person liked drama. Does the least popular movie mean that students do not like this type of movie? Like, no, not necessarily. Okay. Okay, the students, or I should say staff. We'll change this to staff. Okay, the staff voted on their favorite. So they could still like dramas, but just potentially it's not their favorite. It could even be their second favorite, but just not their favorite. So they could still like drama, but it was not voted staff's, like it's like #1 favorite. Okay, how many students said romance was their favorite type of movie? We kind of already talked about that, 6. You just locate romance, you follow the bar up and then over, and it's 6. And then E asks, how many students participated in the survey? So for comedy, it was 4. For action, it was 5. Romance was 6. Drama was 1. We already did that one. Science fiction is 4. So what we're going to do with how many, well, staff participate in the survey. 4 plus 5 plus 6 plus 1 plus 4. We are going to total them up. So when we add all of these up, okay, so it's going to be 20 staff total participated. And F, how many more students like romance than drama? So they're saying how many more students like romance. That means romance is likely going to be a higher number. So romance again was 6. And when we ask how many more, we're going to divide and find the difference. Okay, and then drama is 1. Okay. So 5. So 5 more staff. Elizabeth said their favorite is romance and drama. Example 4. The following histogram shows the heights of 21 students in a class grouped into 5-inch groups. So on the x-axis, it's height in inches and its intervals, 50 to 55. So this would include 50, not include 55, but include 55 here, not include 60, because it's continuous, right? Include 60 here, not include 65. So just as a recap, square brackets include that number, and round brackets do not include the number, okay? And so on. And then the height of the students, the frequency is up the y column, basically the y-axis. Okay, and I already explained this, but note when the height appears in 2 different intervals, such as this 55, it is appearing in the 2 intervals. What we usually do is we usually group it into the upper interval. So it's included, like 65 is included here, 70 is included here, 75 is included here. Okay, so A, how many students were between 60 and 65 inches? Okay, well, let's locate that. It's right here, all the way up, over, that's 5. Okay, so 5 students. And B, how many students were greater than or equal to 60 inches? So what we have to do for this one is we have to consider the intervals 60 to 65, which was 5 students. Okay, we'd have to include 65 to 70, which is 2 students. We'd have to include 70 to 75, which is 3 students. And we'd have to include 75 to 80, which is 1 student. Okay, so the total is 5 plus 2 plus 3 plus 1. So it's 11 students. So 11 students were greater than or equal to 60 inches. So how many students were between 60 to 70 inches? Well, we have 2 intervals here, 60 to 65, and then 65 to 70. Right? We have to include all students that are in both of these intervals. So it's going to be 5 plus 2. Seven students are between 60 to 70 inches. Okay. D, how many students were less than 70 inches? So less than 70. So 70, the cutoff is here because that's 70 and above. So less than 70, we're going to start the intervals at 50. So we have to include this interval here, which is 4, this interval here, which is 6, 5, and 2. We have to include all of these intervals here. 4, 6, 5, and 2. Okay, so 70 students are less than 70 inches. All right, and just for a note, yeah, so we included 50 to 55 interval, 55 to 60, 60 to 65, and 65 to 70. Okay, E. Could you answer how many students were 60 inches tall? So the interval is 60 to 65 inches. We don't know how many people were 60 inches, 61 inches, 62, 63, 64, 65, so on. So we don't know exactly how many were each height. So we do not know the number of students at each height. We only know the number of students in that interval.